You think ocean waves and atoms are different things. You think music and quantum mechanics are separate fields. You think the ripples on a pond and the light from your screen follow different rules. They don't. They're all the same mathematics, same equation, same fundamental pattern. And once you see it, you can't unsee it. Everywhere you look, nature is repeating itself. Not copying, not imitating. Just following the same mathematical rules over and over, because those rules are universal. And that universality is both beautiful and deeply strange. This should change everything about how you see the world. Start with something simple. Ocean waves, rolling toward the beach, up and down, rhythmic, repeating. You've seen them 1,000 times. What's actually happening? Water molecules moving up and down, energy traveling through the medium. The water itself doesn't flow toward the shore. Individual molecules just oscillate, rise and fall. But the pattern, the wave, travels forward. Energy moving through matter without the matter itself moving much. That's wave motion. Now sound, you can't see it, but it's the same thing. Air molecules moving back and forth. Compression and rarefaction. Pressure going up and down. Energy traveling through air. Same behavior as ocean waves. Same mathematics. The wave equation describes both. Different medium, different speed, but same underlying structure. Light. Electromagnetic radiation. Electric field oscillating. Magnetic field oscillating. Perpendicular to each other. Energy propagating through space. You don't need a medium. Light travels through vacuum. But the pattern is the same. Oscillation. Repetition. Wave motion. The wave equation again. Same form. Different variables. Same mathematics. Quantum mechanics. Wave functions. Schrödinger's equation. Probability. Amplitudes oscillating in complex space. Abstract. Hard to visualize. But mathematically it's the same pattern. The Schrödinger equation is a wave equation. Same structure as the equation describing ocean waves. Different interpretation. Different physical meaning. But same mathematical form. This is not a coincidence. This is not nature being lazy or uncreative. This is nature following mathematical necessity. When you have a system that can store energy and transfer it between two forms, that system will oscillate, it will wave, it will repeat, always, because that's what the mathematics demands. Take a pendulum, simple, a weight on a string, pull it to one side, release it, it swings, back and forth, oscillating. Why? Because energy is converting between two forms. At the highest point, all potential energy. At the lowest point, all kinetic energy. The energy sloshes back and forth between these two storage modes. Potential to kinetic to potential, over and over. That's oscillation. That's the fundamental pattern. A spring. Compress it. Energy stored. Release it. The spring extends. Energy converts to kinetic energy of motion. The spring overshoots, stretches beyond its rest length. Energy converts back to potential. The spring compresses again, back and forth. Oscillation, same pattern, different system, same behavior. An electrical circuit, an inductor and a capacitor connected. The capacitor stores energy in an electric field. The inductor stores energy in a magnetic field. Connect them, current flows. Energy sloshes back and forth between electric field and magnetic field. The current oscillates. Same mathematics as a pendulum. Same equation. Totally different physical system. Same behavior. An atom. An electron. It has kinetic energy from motion and potential energy from its position relative to the nucleus. These energies convert back and forth. The electron doesn't orbit in a classical sense. It exists in a standing wave pattern around the nucleus. A wave function. That wave function oscillates in time. The probability distribution stays constant, but the phase rotates. Oscillation at the quantum level. Same pattern. Every one of these systems follows the same differential equation. Not similar. Identical in form. The wave equation. Second derivative with respect to time equals velocity squared times second derivative with respect to position. Different symbols. Different constants. Same structure. Solve it once, and you've solved it for every system. The mathematics is universal, and the behaviors that emerge are universal too. Interference. When two waves overlap, they add. If the peaks align, constructive interference. Bigger amplitude. If a peak meets a trough, destructive interference. cancellation. This happens with water waves, with sound waves, with light waves, with quantum wave functions. Same phenomenon everywhere. Diffraction. Waves bend around obstacles, spread out after passing through openings. Water does it, sound does it, light does it. Particles at the quantum level do it because they're waves. The mathematics predicts it. The experiments confirm it. Universal behavior. Resonance. This one is everywhere. When two oscillating systems have matching frequencies, they couple strongly. Energy transfers efficiently between them. One system drives the other, amplifies it. You see this in music. A guitar string vibrates at its natural frequency. The body of the guitar resonates, amplifies the sound. Without resonance, the guitar would be almost silent. The string alone produces very little sound, but the resonating body takes that vibration and amplifies it dramatically. You see it in structures. The Tacoma Narrows Bridge in 1940. Wind created oscillations that matched the bridge's natural frequency. Resonance. Small wind forces created enormous oscillations. The bridge swayed violently, eventually tore itself apart, collapsed into the river. Dramatic failure, all because of resonance. The wind frequency matched the structure's natural frequency. Energy accumulated, amplitude grew, disaster. You see it in technology. Radio works by resonance. Your antenna has a natural frequency. When electromagnetic waves at that frequency pass by, the antenna resonates, absorbs energy from those waves, ignores other frequencies. That's how you tune to a specific station. Resonance filters out everything except the frequency you want. MRI machines, magnetic resonance imaging, atomic nuclei have natural frequencies. Hit them with radio waves at exactly that frequency. They resonate, flip their spins, absorb energy. When they relax back, they emit signals. Those signals create the image, all based on resonance, matching frequencies. Universal principle applied to medical imaging. Here's where it gets personal. There was a physicist who played bongo drums. Spent hours practicing. Neighbors complained. Friends thought it was strange. A physicist obsessed with percussion. But he wasn't just playing music. He was feeling physics. The drum head vibrates, oscillates, creates standing waves. Different points on the drum have different modes. Hit the center. You excite the fundamental mode. Deep tone. Symmetric vibration. Hit near the edge. Higher modes activate. Higher pitch. Sharper sound. The drum is a physical system with natural frequencies. Harmonics. Same mathematics as a quantum system with energy levels. When you strike the drum, you don't create a single frequency. You excite multiple modes simultaneously. The fundamental, the second harmonic, the third, fourth, all vibrating together. That's what creates the complex timbre, the characteristic sound of the drum. And those harmonics follow exact mathematical ratios. The frequencies are related by simple integers. Same ratios that appear in music theory. Same mathematics that describes electron orbitals in atoms. Play multiple drums together. Rhythms interact. Patterns emerge. Polyrhythms. Complex interference patterns in time. Some rhythms reinforce. Sound tight, locked in. Others clash. Create tension. Dissonance. It's interference. Temporal interference. Same principle as waves meeting in space, but now waves meeting in time. Constructive and destructive interference creating musical texture. Music theory is wave physics in disguise. An octave. The frequency doubles. 2-to-1 ratio. Simple. Clean. Consonant. A fifth. 3-to-2 ratio. Also simple. Also consonant. A major third. 5-to-4. Still relatively simple. Still sounds good. These simple ratios mean the waves align frequently. Peaks meet peaks regularly. Constructive interference happens often. That's why simple ratios sound harmonious. Complex ratios mean the waves rarely align, always shifting, beating against each other. That's dissonance. Not bad, just more complex interference. Pythagoras figured this out 2,500 years ago. He discovered that musical intervals correspond to simple numerical ratios. Built an entire theory of music on mathematics, on ratios, on patterns. He was doing physics without knowing it. Understanding wave behavior through music, the mathematics of vibrating strings, same mathematics that would later describe everything from light to quantum mechanics. Here's what's truly remarkable. These patterns don't just appear in physics, they appear everywhere. Biology, chemistry, geology. Everywhere you look, Fibonacci sequence shows up in plant growth, spiral patterns in sunflowers, pine cones, nautilus shells. Why? Because it's a stable growth pattern, efficient packing. The mathematics of sequential growth naturally produces this pattern, not because nature is trying to create Fibonacci numbers, because the mathematics of growth under certain constraints always produces the same pattern. Fractals, self-similar patterns at different scales, coastlines, river networks, tree branches, lung tissue, cauliflower, everywhere. Why? Because fractal geometry is the natural solution to branching and optimization under space constraints. Nature isn't choosing to make fractals. The mathematics of branching naturally produces fractal patterns. Symmetry. Crystals have it, organisms have it, molecules have it. Why? Because symmetry represents low-energy configurations. Stable states. Nature settles into stable states. Stability often means symmetry. Not always, but often. So symmetric patterns appear everywhere. Not by design, but by mathematical necessity. Stable solutions to physical equations often have symmetry. The wave equation itself appears in contexts that seem totally unrelated. Heat diffusion, same equation, slightly different form, but mathematically equivalent. Quantum mechanics. Schrödinger equation, wave equation. Electromagnetic radiation. Maxwell's equations reduced to wave equations. Seismic waves in the earth. Wave equation. Sound in air. Wave equation. Vibrations in a drumhead. Wave equation. All the same mathematical structure. This is why physics is possible. If every phenomenon followed completely different rules, we couldn't understand anything. We'd have to learn each system from scratch. No connections. No generalizations. No predictions. But nature doesn't work that way. Nature uses the same patterns repeatedly, the same mathematical structures. So when you understand waves in one context, you understand them everywhere. You learn about water waves. Simple, visual, intuitive. Then someone tells you sound is waves. You already understand interference, diffraction, resonance. You've seen it with water. Sound behaves the same way. Your intuition transfers. Then light, electromagnetic waves. Can't see the fields. Abstract, but same mathematics, same behaviors. You understand it because you understood sound. Then quantum mechanics, wave functions, probability amplitudes. Extremely abstract, but same equation, same interference patterns, same resonance. You understand it because you understood everything before. That's the power of recognizing patterns. Each new context becomes easier because the pattern is familiar. The mathematics is the same. Only the interpretation changes. And that's not a limitation, that's a feature. The universality of mathematics makes understanding possible. Think about vibrations. Everything vibrates. Atoms in a solid vibrate around their equilibrium positions. That's heat. Temperature is just the average kinetic energy of vibration. Molecules vibrate. Chemical bonds act like springs. Atoms connected by bonds oscillate. Those vibrations have specific frequencies, modes. When you heat a molecule, you're exciting higher vibrational modes, more energy in the oscillations. Crystals have collective vibration modes, phonons, quantized vibrations propagating through the lattice. These are waves, sound waves in solids. They carry heat, they scatter electrons, they determine the material's thermal and electrical properties, all from vibrations, all from wave motion, all from the same mathematics that describes ocean waves. The earth vibrates. Seismic waves from earthquakes, compression waves, shear waves, surface waves, all wave motion, all described by wave equations. Geologists study these waves to understand Earth's interior. The waves refract, reflect, create interference patterns. Same behaviors as light waves, same mathematics, different medium, different scale, same pattern. Even the sun vibrates. Helioseismology studies oscillations in the sun's surface. Those oscillations are waves, pressure waves, gravity waves. They reveal the sun's internal structure. Scientists use the same mathematical tools developed for studying ocean waves and sound waves. Apply them to the sun. It works, because the pattern is universal. And here's the strange part. We evolved to recognize patterns. Our brains are pattern-matching machines. We see faces in clouds, hear rhythms in random noise, find meaning in coincidences. Sometimes this leads us astray. Pareidolia, false patterns. But mostly it's useful. Because patterns are everywhere. They're real, and recognizing them gives us predictive power. Maybe that's why music affects us so deeply. We're hearing mathematical patterns, ratios, harmonics, interference. Our brains recognize these as fundamental patterns of nature. Not consciously, but somewhere deep in our neural architecture, we respond to mathematical structure. Simple ratios feel consonant because they represent stable, repeating patterns. Complex ratios create tension because they represent less stable interference. Or maybe we just like patterns because pattern recognition helps survival. Either way, the patterns are real. They exist in nature. Mathematics describes them. And those same mathematical patterns appear in contexts that seem completely unrelated. Ocean waves and quantum mechanics, guitar strings and electron orbitals, drum vibrations and atomic oscillations, bridge collapse and musical consonants, radio tuning and MRI imaging, all connected, all the same pattern, all following the same mathematics. This is what physics reveals. Not that everything is waves, but that wave motion, oscillation, periodic behavior, these are natural consequences of energy storage and transfer. Any system with two modes of energy storage will oscillate, will create waves, will follow the wave equation. And because energy storage and transfer are fundamental, waves are everywhere. You can't avoid them, can't escape them. The universe vibrates. Energy sloshes back and forth. Potential to kinetic, electric to magnetic, matter to field, back and forth, over and over, creating oscillations, creating waves, creating patterns that repeat across all scales. And once you see the pattern, you see it everywhere. You look at water, you see wave motion, you hear sound, you recognize interference, you see light, you understand oscillating fields. You learn quantum mechanics, you realize it's the same thing. Different context, different interpretation, same mathematics, same behavior, same pattern. That's the insight. That's the revelation. Nature doesn't have infinite creativity. Nature has limited tools, but those tools are powerful, universal, applicable everywhere. Wave motion, oscillation, resonance, interference. These aren't different phenomena in different fields. They're the same phenomena wearing different disguises. The wave equation appears in hydrodynamics, in acoustics, in electromagnetism, in quantum mechanics, in heat transfer, in seismology, in astrophysics, everywhere. Not because physicists are forcing everything into one framework, because nature actually uses the same framework everywhere. The mathematics is telling us something true about reality. Reality has structure. That structure repeats, and that repetition is what makes understanding possible. If every phenomenon were unique, science would be impossible. We couldn't learn, couldn't generalize, couldn't predict. But nature repeats, uses the same patterns, follows the same rules. So we learn once, apply everywhere, build understanding that transfers across contexts. That's why a physicist studying ocean waves can contribute to quantum mechanics. Why someone analyzing sound can help with earthquake prediction. Why musical training can develop mathematical intuition. The patterns are the same, the mathematics transfers, the insights apply broadly. This isn't reductionism. It's not saying everything is the same thing. Ocean waves and quantum mechanics are different, but they're governed by the same type of equation. They exhibit the same behaviors, they follow the same mathematical patterns. That commonality is real. It's deep. It reveals something fundamental about how nature works. Maybe the universe is mathematical. Maybe mathematics isn't something we invented to describe nature. Maybe mathematics is the structure of nature. And when the same equation appears in different contexts, that's not coincidence. That's nature showing us its underlying unity, its fundamental simplicity beneath apparent complexity. Or maybe I'm reading too much into it. Maybe it's just that certain types of systems naturally produce certain types of behavior. And we've developed mathematics that describes those behaviors. And when different systems produce the same behavior, the same mathematics applies. Not because of deep unity, but because of functional similarity. Either way, the pattern is real, the repetition is real. Ocean waves, sound waves, light waves, quantum waves, vibrations in drums, oscillations in circuits, resonance in structures, interference in music. All the same mathematics, all the same pattern, all connected by wave motion. And when you see it, really see it, everything changes. You stop seeing separate phenomena. You start seeing variations on a theme. The universe becomes simpler, more unified, more comprehensible. Because the patterns repeat. The mathematics is universal. Reality is structured. The wave equation, simple, elegant, universal. It describes ripples on a pond and the evolution of quantum states, sound propagating through air and light crossing the cosmos, vibrations in a crystal and oscillations in the sun. One equation, infinite applications. That's the pattern. That's nature repeating itself. And it's beautiful every single time. You look at waves now, ocean waves rolling in, and you don't just see water, you see the universal pattern, the same pattern that makes music possible, that makes atoms stable, that makes light travel, that makes reality comprehensible. All there, in the waves, in the oscillations, in the eternal repetition of nature, using the same mathematical truth over and over. That's what the patterns reveal. Not simplicity, not reduction, but connection, unity, the deep mathematical structure that underlies apparently different phenomena. And once you see it, you can't unsee it. The patterns are everywhere, in physics, in music, in nature, in mathematics, all repeating, all connected, all beautiful. Nature repeats itself, not because it's unoriginal, because it's mathematical. And mathematics has preferred patterns, stable solutions, universal structures. Wave motion is one of them, perhaps the most important one. And recognizing that pattern changes everything.